Alright, here begins your review. We're going to try to go through this as quickly as we can. First, for number 1, no, this is not a function because we're not going in the right order. My x elements should be my domain, and in these ones they are backwards. B is the same thing, except we are in the right order now. We have everything in our domain, all 4 elements are being sent somewhere, and no element is being sent to 2 places. So no elements reversed for number 1, and number 2 is good. Elements were reversed. Number 3, same thing, all elements are being sent somewhere to only one place, so we're good. Number 4, we don't have 6 being sent somewhere. 6 is not math, so we do not have a function here, so no. And for E, notice that we have 3 being sent to 2 different places, so no, because 3 is, we'll say that is mapped twice, is how we'll say that, mapped twice. Alright, for 2 through 5, we're looking vertical line test. So do I hit it twice anywhere? Well, obviously right here, I do, so my answer is no. I'm clear here, so yes. I'm also clear everywhere here, so yes again. But right here, when I do that vertical line, I'm touching it twice, so no, they will not be vertical line, or we do not have a function there. 6, 7, 8, 9 is very similar to part 1. Everything from the left has to be matched to something in the right and one and only thing. So this is a good function. This one for number 7 is not, because number 3 here gets mapped to 2 different places. Again, 3 is mapped twice. That's our reason. 3 is mapped twice. Number 8, even though it's all going to the same thing, everything is getting mapped, so we are in good shape. Number 9, no, because 2 is not mapped. 2 is not mapped, so we cannot say we have a function. Alright, so that one should be easy points, as should these. All we have to do for most of them is just plug in a number. So when I plug in 2, I plug in 2 for x, 2 squared is 4, minus 2 is 0. When I plug in 0, 0 squared is 0, minus 4 is minus 4. When I plug in negative 4, it becomes a 16 when I square it, minus 4 is 12. F of 12 is going to give me 144 minus 4. So I'm going to have an answer of 140. And then this is a tough one here. Wherever I see an x, I now want x plus 1. So x plus 1 squared minus 4. You got to that? That's pretty good. I want you to try to expand that, though. X squared plus 2x plus 1. And then still that minus 4. So this should be x squared plus 2x minus 3. Okay, for this next one, same thing. When I plug in, I should get 12 here, 4 for x. This one, instead of x, they want r, so 2r plus 4. Pretty simple. For 7, it should be 14 plus 4, which is 18. When I plug in negative 10, I'll get negative 20 plus 4, gives me negative 16. And then x minus 3 here means 2 times x minus 3 plus 4. And I'll distribute that to get 2x minus 6 plus 4, or 2x minus 2. And this last one over here, plugging in 0 is pretty easy, gives you 15. Plugging in 5 should give you 75. Plugging in z, again, just replace x with z, so 12z plus 15. Plugging in negative 9 should give you a big negative number. You should get negative 108, I believe it is, and then plus 15 will give you a negative 93. And in this one, plugging in minus x, all you're going to do is 12 times negative x plus 15, which means you'll have a negative 12x plus 15. Alright, pushing forward here. Give you a little sneak peek of some of the answers there. So start with ones like 13, where we have polynomials. Polynomials, anything x squared, x cubed, x to the 5 millionth, anything to some power, there's no number that's going to give me any issue. There's no number that I'm not allowed to plug in for x. So this is going to be all real numbers as our answer. If you like writing it like this for the all reals, then you can do that. Number 18 is also like that. It's just a polynomial, a bunch of x terms combined together. So negative infinity to infinity for those, or again, all real numbers. Now another kind are ones like 14 and 15, where we have these square roots. You cannot take the square root of a negative number. So all I'm going to look at is whatever's under the square root. So 25 minus x, it has to be positive. So it has to be bigger than or equal to 0. That means 25 here must be bigger than or equal to x. So I need numbers that are less than or equal to 25. Well, I'm going to start at the very beginning then. negative infinity all the way up to 25. And because of that equals, I want to include it, so I'm going to have a bracket. Number 15, same way. X minus 3 must be bigger than or equal to 0. That means that x will be bigger than or equal to 3. The smallest number I can have is 3, and I want it, and I'm going to go all the way up to infinity for that one. Alright, and then last kind are 16, 19, and 20, where we have these fractions. The only number you can't divide by is 0, so I'm just going to set that denominator equal to 0. I will have to factor these. This will become x minus 2, x minus 1 to equal 0. That means I'll have x equals 1 and x equals 2. So what I'm going to do, I want all numbers except for those two. So where do I start? At the very beginning with negative infinity. I'm going to go from negative infinity all the way up to, well, where's my first break? 1 will become before 2, so negative infinity to 1. I want to start right back up on the other side. I have to look at everything between 1 and 2. So from 1 to 2, and I stop again. And then I start back up right at 2 and go on again forever, 2 to infinity. Alright? Number 17, we aren't going to talk about much, but just for your reference and so you know, a cubed root is different than a square root. Cubed root, we always have all real numbers for this one. Don't worry, you won't see one on your test like that, but we'll talk about it down the road. Alright, let's go to 19 and 20 now. 19, even though this 3x up top doesn't change anything. 3x is a polynomial, it doesn't matter at all. If this was something like a square root, hint, hint, you'd have to look at that too. However, all we want to really care about is the denominator in this problem. That's the only thing that can cause us issues. So set it equal to 0, factor the 35 that subtracted 2, that means I'll have x minus 5 and x plus 7 equals 0. So my x values will be 5 and negative 7. So again, which are we going to look at? We want all numbers, so I'm going to start at infinity, negative infinity, and I need to get up to one of these. The first number I'll hit is negative 7. So that's where I got to stop. Start back up at negative 7 and go up to my next number, which would be 5. And then start back at 5 and go to infinity. Alright, and now this last one here. Let me get this guy out of the way. This last one that I'm going to look at will be, we need to factor this bottom again. Well, first I have an x in all of them, so make it x squared minus 5x minus 24 once I factor out that x. Now I can factor this part. Factor the 24 that subtracts to give me 5. Factor the 24 that subtracts to give me 5 should be 8 and 3. So I'll have 8x minus 8, x plus 3 here equals 0. So I'll get x equals, don't forget this one here, it'll be 0, x will be 8, and x will be negative 3. So this one should have 3 breaking points. So I should have 4 different regions. Start at negative infinity. I'm going to go up to my first number here will be negative 3, my lowest number. Start up on negative 3 again, go up to my next break point, which is 0. 0 to my next break point of 8, and then 8 the rest of the way to infinity. So domains are the big part of these to make sure we know how to do. Okay, pushing forward. Now we want to look at proving being even, odd, or neither. For everything, we just want to plug in negative x. So f of negative x here is negative x squared plus a negative x. That's the same as x squared minus x. That's nothing. It doesn't tell us anything. This is going to be neither right off the bat. This one here, if I do f of negative x, will give me the absolute value of negative x. Well, absolute value is going to make everything positive. So this is going to be whatever the square or the absolute value of x was anyway. And that is exactly what f of x was. So when it's the exact same thing, we say it's an even function. 23, if I do f of negative x, I get negative x cubed minus negative x. When I simplify that, that's the same as negative x cubed plus x, which is the opposite of my original function. That makes this an odd function. Number 24, f of negative x is 2 times negative x to the 4th minus a negative x squared plus 7. When I simplify, it's just 2x to the 4th because this will go away, negative positive, minus, I have 2 of these, so it'll be just regular x squared plus 7. This is, again, f of x That means that I have an even function. Number 25, when I look here, f of negative x here will be negative x cubed plus a negative x minus 10. Simplifying, negative, positive, negative, so it'll be negative x cubed minus x minus 10. The first two terms are opposite, however, that last term there is the exact same. So I can't say anything about this one. Can't say it's either odd or even. So I'm just going to say it's neither. For number 26, it looks complicated, but it's really not. When I take it an even number of times, when I take negative x to an even power, it's going to go right back to where it starts. That's kind of why we call it an even function. So minus negative x squared. So when it's an even power, it'll just go back to normal. Even power, back to normal. Even power, back to normal. That's the same as f of x, so I have an even function. Alright, number 27. What I have here, if I do f of negative x, it'll be negative x squared up top plus 1 over this is a negative x. And so from there, if I try to simplify that, x squared plus 1 on the top, negative x on the bottom, well, I can pull that negative out front. Negative x squared plus 1 all over x. That's the same as negative f of x. Because of that, that makes this an odd function. And number 28, f of x equals 4. Well, if I do f of negative x there, well, f of negative x is still 4, which is f of x. So because of that, it is an even function. Pretty straightforward and actually a little bit easy. So easy that I messed it up on the answer key. Go figure. Alright, coming on the home stretch, we want to look at increasing and decreasing intervals here. So let's start with where I'm increasing. Actually, I'm going to go one range at a time. So I'm going to start here. My first thing, I'm going uphill. So starting at negative infinity, I'm going uphill until I hit this mark right here. I want to look at my x values. My x value right there is negative 6. My next interval here, for my x values, goes from negative 6 to about, what do we say, negative 3. Negative 6 to negative 3, though, it's constant. It's not increasing or decreasing, so we won't look at that at all. Now here, from negative 3 to this point right here, we're decreasing. Look at my x values. So from negative 3 to this x value of 0, I am decreasing. My next interval, from x and 0 here to x equals 4, I'm increasing. So 0 to 4 is increasing. And then decrease in my next interval, going from 4 to 6. So decreasing from x equals 4 to x equals 6. Then I increase the rest of the way from 6 all the way up to infinity. Alright, I'm going to do the exact same for this one over here. I'm going to look where am I increasing, where am I decreasing. Starting off the bat, I'm going downhill. So decreasing from negative infinity to this first point here. This first point is at x equals negative 4, right there. My next interval will go from negative 4 to here at negative 2. And what am I doing there? I'm going uphill. So negative 4 to negative 2 is increasing. Negative 2 to 0 for the x values, make sure you use your x values. I'm decreasing again, negative 2 to 0. I then go back up until I hit a positive 2. So starting at 0 to positive 2, I'm going uphill. Downhill one last time, it looks like here, from x equals 2 to the next one where x equals 3. So from 2 to 3, I'm decreasing, and then I increase the rest of the way from 3 up to infinity to increase to end it. Alright, and the last one. All we're doing is saying, do we have functions, are they one-to-one, all that. Function, vertical line test, yes, it is a function. One-to-one, horizontal line test, nope, not going to work. It hits it twice, so no, it is not one-to-one. Domain here, the domain is going to be all real numbers. The arrows kind of help you to point that out. The range, however, look where I stop. Look where my range is. I'm going to stop at negative 2. So negative 2 is my lowest number. I want to include it. Negative 2 to infinity are what my y values are. Where am I increasing? I'm increasing starting at this point and going up forever. So from when x equals 0 to infinity, I'm an increasing function. I decrease on the other end. starting at negative infinity, and I decrease until I hit that 0. Y-intercept, where do I touch the y-axis? Well, I touch it right here at this point. That point is 0, comma, negative 2. My x-intercepts, there's a couple of them. They're at negative 2, comma, 0, and at 2, comma, 0. Even or odd. If it's even, I should be able to flip it across this x-axis. So if I were to flip it, it would look the exact same across, not the x-axis, I mean the y-axis. Because of that, it is an even function. For it to be an odd function, I would have to flip it both over the x-axis and the y-axis. That's what would make it an odd function. Alright, now for number 32. Is it a function? Yes. There's no vertical line test issues. One-to-one, again, yes, because horizontal line test looks just fine. Domain, negative infinity to infinity. Range, is there anything that it doesn't touch? Not really. It keeps going forever. So range is good. Increasing, it's a line. We're going uphill the entire way. There's no dips and curves. So it is increasing everywhere as well. That one's pretty simple to see. Is it ever going downhill? Nope. No answer. It's never decreasing. Y-intercept, where does it touch the y-axis? That's at the point 0, comma 2. X-intercept, where does it touch the x-axis? That's at negative 3, comma 0. Make sure we're looking at these ordered pairs when we do that. Even or odd, we're going to say actually it's neither here. Neither even nor odd, because if I flipped it over the y-axis, tells us nothing. If I flipped it over both axes, it's definitely not the same. So it's neither even or odd. Well, there you have it, your review, and hopefully you should be in good shape to get a great score to start off the semester in this class.